Hello YouTube, Sort of Smarter. Today we're out in the shop. Thought we'd try a multi-part project. My wife has a to-do list, so to speak. She has whole bunch of seeds that she would like to get planted of some lilies, and they take a couple years apparently before they will start to flower, and she would like to start them germinating over the winter time. So thanks to bigclive, we found these driverless LEDs. So I picked up a couple of these. These are 50 watt full spectrum grow lights, 110 volt, 60 hertz. And these are extremely bright, and I'm not going to go into the specs on them. I will put the links down below when I post the video so you guys can see them. I like getting these off of AliExpress. They're a lot cheaper. I get them a lot faster. So I'm going to see if we can't do this build and see what we can't break or blow up. They do get really hot, so I've picked up a heat sink that it mounts to, and we're gonna drill some holes, use the holes as a template, mount it to the heat sink and a fan. I've got one of these automatic temperature switches that turns himself on. I'll just pull the sleeve off there. I don't know if you can see that. They come on at 40°C. They're about a few degrees off. This will handle 5 amps at 250 volts. We're just going to use it at 12 volts to run this real simple fan. This is an old Pentium 2 heatsink out of a computer that I salvaged at my local computer refurbishing store. And this is just an old, out of the scrap bin, just a 12 volt 1 amp power supply. It converts 110 volts down to 12 volts 1 amp. You can see here the 4 diodes for the rectifier and all the rest of the circuitry. I'm not going to go into how that all works. I don't this isn't that kind of video for that, so if you guys want to look that up, you guys can find all that information. Power cord on here, I am going to use a 3-wire, so I will ground the heat sink, so it is earth ground. And we'll get into it. So I am going to mount the power supply against the heat sink on here, so I'm going to use some plastic spacers to keep the back of the power supply off of it, so the connections don't ground themselves to the heat sink. Otherwise I'll short it out and that won't be any fun. Some heat sink compound against the back of the LED, keep it from overheating. And yeah, so let's get into it. Sorry about the cut in the video. The neighbor decided to fire up his boat and run it for an hour. Didn't think you guys wanted to hear that. So thought I'd save you the agony of listening to that thing run. That would be cheap Chinese drill bits. But onward. Yeah, this will be the second one of these I've built. First one I did, I kind of a learning curve. I didn't put it on a heat sink and the thing overheated and they started shutting down and LEDs got really hot and color started changing on me, and I figured out real quickly that I needed to put it on a heat sink, and so I mounted it to a heat sink and it lasted a little bit longer, and then I discovered I needed to put a fan on it, and then I discovered it didn't need a very big fan, and I didn't want the fan running all the time, and it doesn't really need the fan on all of it, and so I got these little heat switches, and they're a few cents on AliExpress, makes it kind of nice. So kind of a progress, continual learning curve. The power supply, this one's just kind of scrappy. I ordered some 3-watt LED drivers from AliExpress. They're just not here yet, and I didn't feel like waiting for them to show up before I started putting this together. So just dug out an old janky 1 amp wall socket power supply that'll work just fine. I do a lot of junk store shopping. Buy a lot of secondhand electronics and garbage like that, so that I'll salvage a lot of the pieces and parts out of them so that I don't have to buy everything new. I don't have a big budget. Have to do a lot of explaining to the wife why I spend a lot of money on some stuff. Keeps me out of trouble that way. And so, you know, build her a nice super bright LED powered greenhouse light and score some extra brownie points with her. See what keep me out of trouble for a while. All right. Okay. Got a nice dollop of the thermal grease on it there. Let's see if we can get these to start. I think we might end up having 3 screws instead of 4. A 4th screw hole is not centered. We'll see how it tightens down. Alright, so I kind of cheated and slotted the hole right next to it on the chip. After inspecting the chip, realizing that there's no circuitry there, it was much easier than trying to re-drill the hole in the heat sink. Probably not the best way to do it. Next time I do the next chip, I will definitely have to make sure that I center the holes a lot better. To get these 2 screws in better, because if you noticed before I paused the video, they in order to get them in better, I had to cut the screws in half. They were too long, and I don't have any shorter M3s, so so. That's just the brakes on there. So there we go. Got a little bit of heatsink compound coming out on both ends of it. And I know that it's compressing itself down all the way. I'll wipe off that excess heat compound. Alright, so this will reattach back onto here. This is the heatsink that came, or the fan that came with it. It's got clips that mount it onto here. I'd removed it before the video, just because I didn't want to have it on there and have metal shavings going inside of the fan before the video. So that onto there. There. Alright. So we're partway there. Heatsink, LED mounted to heatsink, fan mounted to heatsink. Now we need to figure this one out. These are the connections for the high 110 volt input, line and neutral. These are the outputs for the positive. I don't know if you can see that on there. This will focus. You can see the positive and negative output on there. And I think we are going to mount that like so. Just because the line and the neutral are here as well. We'll run a pair of wires across from here. We're going to strap the cord. I think we'll mount it on this side because the temperature sensor is going to go here. We'll epoxy that to here. And mount its outputs on here. Across there. So that one there, that one there. Alright, so I think for this one, what I'm going to do, I'm actually going to epoxy this way. cut off one. I will just cut one off, sand the end of that flat. We're going to glue that directly onto the circuit board on that corner there, those 4 corners there. Just like that. I think that will work just marvelous. Nothing special, just a quick set 1-minute epoxy. I buy the quick epoxies, I'm impatient. Oh, there it is. It's done. Alright. Okay. Sorry about the interrupt there. Figured I'd pause the video to let the epoxy set cure a little better. So. It's still a little soft. I may end up pausing and coming back to a later date, but you can see there we've got a nice standoff on there, so good separation between the positive and negative on the line input on there, and you can still get to the positive and negative on the output here. So. But at this point, we can at least get the epoxy mixed up for the thermal switch. I like using a steel weld epoxy for this one. That way I get good thermal transfer. Yeah, put that all mixed up there. Get a nice good coating of that one on there. Nice good coating of that. Yeah, that's good. Yep, I think that's a good. I think we will pause at this point. We'll come back here in a little bit after that cures and continue on. I will be back. Alright, now the epoxy is set on it. Let's get something done. So, don't need the plug, and we don't need the blue wire, we just need the red and black. And let's see here. Let's see what do this. Soldering iron plugged in. Oh, sorry, out of frame again, bad habit. So I'll get that zip tied together there in a second. So negative to the fan, positive out through the thermal switch, back to the fan. Let's see how we want to do this here. flow some fresh solder across those pads because I always use lead-free solder. Stuff is just junk. And we got that. Sorry about bumping the head on there. I think our frame. We'll get this ground on there, and we'll get some jumpers over to the. We'll get some other wire here. I will be back in a moment with some wire. Okay. So I got some wire. We're gonna try this on there. We'll get it here, get it tinned. Of course not. God, it's got to be the worst solder joint ever. Don't judge me. Sorry if my head was in the way. Trying to see around the camera isn't easy. So got that. Let's make a good ground connection here. Sorry, I'm off camera. Will that fit it? Maybe. We'll try it. We'll crimp it. Get the Allen wrench back on there. Get that screw out. Let's try to keep from electrocuting ourselves. Take that screw back out. Squeak, 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 squeak. Out. You know what? I'm gonna get a washer. I will be right back. Try that. Is that too big? No, that's too big. Alright. It's gonna slip right through. Nope, it won't. Alright, no washer. Ew. We will just call this Frankenlight. Proof of concept, right? Honest, honey. It'll grow beautiful flowers. I don't care how ugly the light looks. Alright, well. That is a really ugly weld. Let's see if we can make that better. That is better. A little bit better. Alright, boys and girls, the moment of truth. I won't point it at the camera to be nice. Moment of truth. Let's plug it in. Well, sorry about the exposure there. I will cover it up. Well, the LED is on the power circuit. Let's grab a rag here and cover that up a little bit. There you go. Let us turn on the voltmeter and see what oh, look, fan is on. Yeah, that heatsink is definitely warm. Guess I don't need to check voltages. Yeah. Well, all right. Well, a little sloppy, a little chaotic, some half-ass bolts, cut them off, and I got some decent heat flow. But that I call that a success. I guess on the next build, or the next part of this, we'll start a frame for the little miniature greenhouse, and I'll get some thermocouple, and we'll check temperatures on that light and see how that works. For now, YouTube, we'll talk to you later. Have a good day.